Thank you very much for you having me here. And I'll be talking about scientifically based criteria for evaluating the qualitative composition of platelet-rich plasma. So first, briefly, I'll be talking about a little bit about T-Lab. T-Lab is the first PRP manufacturer, and our core business is regenerative medicine, and we develop, design, manufacture, and design protocols for having the better platelet-rich plasma and stromal vascular fraction medios of the different tissues, like from blood or the fat tissue. So we have been nominated one of the biggest global platelet-rich plasma market reports, and we are trying to develop our things all over the world. I'll be talking about T-Lab PRP kit and tubes. As I told you, we design, we make the R&D, we make the manufacturing, we have our own sterilization facility, and we do the sales and marketing. And our quality certifications, mainly the quality of the medical device manufacturing is from Lloyd's Register, and our product is already been in the market for Russian Federation. Regarding to have the platelet-rich plasma, we are focusing on something that what we are injecting into the patient. So it's a new standard of analyzing and understanding the final injectable milieu of platelet-rich plasma, which is called DEPA classification. And finally, you may have some scores if you go forward for it. DEPA is standing for dose, efficacy, activation, and purity. It was first proposed by a French group, which is the DEPA classification, a proposal for standardizing PRP use and retrospective application of available devices. Generally acceptable criteria for DEPA score is between 60 to 65% of platelet recovery, and the final injected platelet-rich plasma is formed of 90 to 95% of purity levels. So this is a simple one. So our DEPA relation is coming way back from years. So we are being invited to many congresses and events all over the world for trying to develop the standardization of platelet-rich plasma and also other milieux from other sources of tissues. So we use to analyze what we are injecting is having that we need to have a protocol for that. Use of platelet-rich plasma in regenerative medicine, technical tools for correct quality and control explains a wide variety of what you have to do in terms of having the DEPA score and understanding the DEPA quality. So with that one, you need to have a hematology analyzer, of course, and with the sampling, we are using an EDTA in order to prevent any further coagulation or aggregation of the platelets in vitro. So it's better to have these ones in order to understand and analyze the final injectable of your platelet-rich plasma. So you probably know, many of you are or having been using the platelet-rich plasma. Simply, you can see on this table, you have harvested the blood from your patient into a tube or any other vacant containers. You may be adding some sodium citrates from other sources, or you may be having the sodium citrate or other anticoagulants within the tubes. The T-Lab PRP product is a tube system product, but we don't use the gel inside the tube in terms of having safety and efficacy levels of the platelet-rich plasma preparation. So most of the times, you know that after centrifugation, you have sedimented all the RBCs, red blood cells, because they are too much and they are way bigger compared to platelets and leukocytes. And you probably are focusing on having buffy coat layers, but I will be explaining something different, because within the buffy coat layer you have platelets, okay, but also leukocytes. Maybe in some indications you may not want leukocytes. And the mid part is known as platelet-rich plasma, and the upper part is platelet-poor plasma as known. But we are approaching in a different variety of understanding of the whole plasma, maybe the platelet-rich plasma too. You can see on the right side here, the whole plasma is platelet-rich plasma, and the rest of the part is separated red blood cells and the level of the leukocytes within the platelet-rich plasma is being decreased, which is called also leukocyte-poor plasma. So those compositions all have been studied at IMCAS in France. I told you that we have been invited there, so there are plenty of different devices from here. You can see very different compositions, especially the last one here you can see is full red one, but believe me, they are all called PRPs. But you can see that some are on the yellowish part, some are high amount of volume or very less amount of volume, but according to the devices. So the devices, and from those devices, the protocol of obtaining platelet-rich plasma is crucial. You can see different types of platelet-rich plasma, but in order to understand what you are injecting, DEPA is crucial, or DEPA becomes crucial. So how to understand the injected platelet-rich plasma is good or not? So you have to focus on platelet counts, of course, but many of the competition or the physicians are focusing on microliter counts of platelets. But when you give it to the hematology analyzer or CBC analyzer, you are having the number of platelets per microliter, but you are injecting in milliliters. That means thousands of times, let's say 4 milliliters of platelet-rich plasma is being injected into your patient. That means you are injecting 4,000 of microliters. So you need to make a calculation in order to understand and analyze the PRP. That's why we are not talking about millions of PRP, because when you say millions of PRP, you are considering the microliter level of it. So that means you may have billions of PRP that is being injected into your patients. So the anticoagulant choice is important. If you are using a system that requires the sodium citrate to be used from outer sources, that means you have enormous amounts of risks of contamination or some other problems because you may not know how to keep for the further patients. Platelet purity is meaning that what you are injecting and what is the percentage level of the platelets alone. So we have done more than 2,000, maybe 3,000 of in vitro trials to analyze and validate the protocol. We use different anticoagulants, we use the techniques of prevention of aggregation, we use different type of centrifugations, and we have analyzed the optimal results. And due to injection, due to having the platelet-rich plasma to be injected into your patient, we need to analyze and finalize to know what will be happening afterwards. So platelets needs to be activated. Platelets are able to be activated outside the human body with the use of ADP, collagen, or calcium chloride, etc. But also it can be activated in vivo with the interaction with some other transcription factors and the coagulation factors too. So on the right side you can see the disc shape of platelets which are non-activated, and the other side you can see the activated platelet-rich plasma with the protruding pseudopods. They are attaching to one another to form a fibrin glue formation of activated cells. And as human beings, we are lucky that we have the ability of those cells to be activated 3D formation, which is good mostly for the facial rejuvenation of injections. You can go deeper layers, or you can inject transdermally, and it can create these type of forms in vivo.